Now the next speaker is Miss Rana Kamill from British Telecom. She will be speaking security, privacy and trust in IoT ecosystem, the oneM2M way. Ms. Kamill, your floor is yours. You are available.
Hello, thank you very much for the invite. I apologize in advance if there are some problems with my connection, so I hope it will be stable until the end of the presentation.
Yeah, please carry on.
Okay, thank you very much. So for the first 10 minutes, I will be talking about oneM2M, and then for the rest of the presentation, I will be talking about security functions in the oneM2M technical specifications. Can we move on to the next slide, please? Okay, so when we compare the Internet of Things to the standard Internet of Computers, we may find that there are lots of largely unattended devices. They are not always attended by owners like normal computers. They can go through harsh conditions of physical exposure, potentially highly mobile. There is a multitude of small developments and deployments, lifetime loss from months to decade, constrained power, memory, and processing in comparison to the normal computers, weaker and more entry points, unmaintained software in comparison to the frequent software security patches, more accessible and by hackers, and real-world impact in terms of physical safety. So if an IoT device is compromised, it may also have it may also impact physical safety. Can we move on to the next slide, please? 40% of economic impact of IoT requires interoperability between IoT systems. The source is McKinsey Global Institute analysis. The same study shows that there is a potential economic impact of $11.1 trillion in the IoT industry. So interoperability between factories, cities, retail environment, and work sites would be absolutely essential to make the most out of the growth of the IoT market. Next slide, please. So at the moment, the market is highly fragmented with small vendor-specific or sector-specific solutions. There is a lot of reinventing the wheel happening, same services developed again and again, and there is limited communication and high integration costs between sectors like building, energy, and security. So an integrated solution is needed. Next slide, please. So why oneM2M? oneM2M is the only standard du jour dedicated to enable horizontal IoT integration, data management and data historization, information sharing, very dynamic privacy and access control, secure. We will talk about this in the next part of the presentation. There are multiple levels, storage and exposure for historical data, data search and aggregation, context information, dynamic data, real-time control, field device management and network technology independence. There is native device management, it is flexible in deployment to adapt to the requirement of various domains, scalable architecture, inter-provider native support, designed to be an internetworking framework for legacy field and core server technologies, other technologies, and proprietary solutions. It is also enabling semantic information sharing, and it is internet friendly for human interaction. Simple if you use the core functions and know your deployment architecture. Next slide, please. Opportunities and problems. So diversity is the richness that allows evolution and innovation. Combination of services is the biggest opportunity for the future. Fragmentation of solutions and technology is the enemy, which is delaying and blocking developments. So what we need is to simplify the environment, remove the unnecessary duplicated solutions, preserve the necessary solutions specializing by internetworking. Next slide, please. So we need to support the developers community, accelerating the development of IoT, to transfer the competition from integration and platforms to services, unlocking the market, to reduce the cost due to the silos approach and its management, and to enable inter-technology and inter-domain data sharing, generating new services and new business opportunities. We need to do that by reducing platform development and integration costs, which will enlarge the market and enable real competition on services. Next slide, please. Oh, we can skip the previous one. Okay, so oneM2M standard is based on a store and share resource REST-based paradigm. The data may be made available in the platform to the other applications, interested applications, and notified by means of subscription. Privacy is ensured by strict access control management, which relies on underlying network security, providing a secure light solution. oneM2M is heavily reusing underlying network functionalities, including TR069, LCS subscription management, and QoS. And it is, as we mentioned earlier, an internetworking framework designed to connect the different IoT technologies. Next slide, please. oneM2M integrates the vertical silos, smart energy services, smart transportation services, and smart infrastructure services. Next slide, please. Next slide again, please. You can skip this one. Okay, so security in oneM2M release 2 to release 4, and also release 5, which we are currently working on. There are various security functionalities which are featured in oneM2M, like enrollment services, secure communication services, and access control and authorization services. Next slide, please. So oneM2M secure environment and security levels. There are various security levels in oneM2M. Secure environment concept abstracts the security implementation. So it exposes common services to applications depending on implementation and provides common interface for remote security administration if needed. It supports 4 distinguished security levels: no additional security, software-only security, trusted execution environment, and tamper-resistant hardware-embedded secure elements. The no additional security, devices otherwise protected from attackers, so trusted networks, basically. Software-only security, it is rather vulnerable to sufficiently motivated attackers, but it is acceptable when compromise is not critical. Then we have trusted execution environment, TEE, relying on main CPU hardware. It is a good barrier against software-based attacks, sufficient for remotely accessible but not physically exposed devices. Then we have the tamper-resistant hardware-embedded secure element, ESE, required to protect secrets within devices physically exposed to attackers, SPA-DPA. Like, for example, to protect unattended devices against cloning. Next slide, please. So we have a lot of features in our release 2, release 3, and release 4 technical specifications. We will be focusing in this presentation on the security ones, including dynamic authorization, end-to-end security, enrollment and authentication, distributed authorization, decentralized authentication, interoperable privacy profiles, secure environment abstraction. Next slide, please. So oneM2M provides a common set of security capabilities to secure IoT devices and applications and prevent and mitigate attacks. It exposes an abstracted set of security-related APIs to help simplify security for IoT devices and applications. Next slide, please. We will talk about the main security functions supported, then we will go through some of them in detail later in the presentation. So the main security functions supported are identification and authentication. Identification by checking if the identity of the request originator provided for authentication is valid. Authentication is validating if the identity supplied in identification step is associated with a trustworthy credential. Secure association establishment, which is establishing a security context between communicating entities to provide confidentiality, encryption, and integrity. Range of authentication options supported for security association establishment. Authorization, access control, is authorizing services and data access to the authenticated entities. Then there is remote provisioning. Next slide, please. Identity protection, the capability to use pseudonyms to protect the anonymity of transactions. Sensitive data handling, capability to protect sensitive data, local residence, for example, and functions like data encryption and decryption in a secure environment, like a smart card or a virtual smart card. Security administration related to device management. It creates and administers dedicated secure environments and post-provisioning of master credentials. Next slide, please. Okay, so we will talk about some functionalities in a bit of detail, like enrollment and provisioning. So enrollment and provisioning, onboarding. Onboarding is the procedure of bringing IoT field devices into operation in an IoT network. Procedures must cope with large variety of field devices types and service providers' business models. oneM2M has specified an M2M enrollment function, MEF, which enables stakeholders to set up the preferred onboarding and enrollment mechanisms in an interoperable way. Next slide, please. Sorry if I'm going a bit fast. I'm trying to make sure that I cover all the functions in my given time. So enrollment and provisioning, onboarding. M2M enrollment function can trigger the field device to execute a variety of procedures, including configuration of field devices with registration parameters, oneM2M identifiers and contact information, provisioning of symmetric keys, and provisioning of certificates. Keys and certificates can be provided for securing oneM2M communication across a single communication hop or across multiple hops in an end-to-end fashion. M2M enrollment function is operated by M2M service provider or a trusted third party, device manufacturer, underlying network operator. Next slide, please. So continuing the M2M enrollment function, MEF. M2M enrollment function allows 3 types of remote security provisioning. Symmetric key authentication, RSPF, certificate authentication, RSPF, and GBA authenticated RSPF. In this case, the MEF is the bootstrapping service function, BSF, of 3GPP generic bootstrapping architecture, GBA. The MEF can trigger the field device to execute a variety of procedures, including configuration of field device with registration parameters and authentication profiles applicable to the operation security framework, which will be visible in the next slide, provisioning of symmetric key credentials, provisioning of certificates, certificate using EST and SCEPF specified by IETF recommendations. MEF is operated by M2M service provider or trusted third-party device manufacturer, underlying network operator. Next slide, please. Now we talk about message security between adjacent entities, the operational security framework. Using Datagram Transport Layer Security Protocol, TLS DTLS version 1.2, several security association established frameworks are supported. authentication and session key establishment using symmetric keys shared by devices, authentication and session key establishment using certificates provisioned to devices, authentication facilitated by an M2M authentication function MAF hosted by M2M SP or third party, as shown in the diagram. Next slide, please. Authorization and access control. So oneM2M is based on a RESTful architecture. API is based on requests to perform an operation on a resource. Operations are create, retrieve, update, and delete. oneM2M service layer supports configurable access control policies that define clear roles dictating for each resource who is authorized to access, what operations are allowed and under, which conditions like time and location of entity are followed. Next, please. So resource access is authorized based upon satisfying at least one of the access control policy, ACP rule, in one of the linked ACPs. Next, please. Dynamic authorization is a different type of authorization. The originator or hosting CSE requesting authorization of originator provided by a dynamic authorization system, DAS server. Direct dynamic authorization hosting CSE submits requests to DAS, originator not communicating with DAS server. Indirect dynamic authorization, the originator submits requests to DAS server using info provided by hosting CSE, similar to open authentication mechanism. DAS has multiple options for authorization, issue or update access control rules, assigning rules to the originator, then issuing a JSON web tokens JWT. Next slide, please. Privacy Policy Manager is the last function that we will go through in this presentation. Next, it is shown in this diagram. Next slide, please. So the Privacy Policy Manager is a personal data management framework. It's a very important one. The PPM converts a user's privacy preference into access control information in order to protect the user's personally identifiable information, PII, from access by unauthorized parties. Access control information consists of static and dynamic access control policies, ACP. The PPM uses terms and conditions markup language to derive consensus between users' privacy preferences and an application service provider's privacy policies. Next slide, please. In the next slide, there is a link to the developer's guide. Next slide, please. For more access to oneM2M material, you have various links here to the website, developer's guide, technical questions, public specifications, webinars, YouTube channels, and events. Next slide, please. Thank you very much for your time. I hope the presentation wasn't too condensed. And if you have any further questions about any of the security functionalities, please email me at the following address. Thank you very much once again.
Yeah, thank you, Mr. Rana Kamill, for your presentation on oneM2M and oneM2M security. It's really very informative presentation and will help in the development of the ecosystem.